Hey, hello, and welcome to why async awaiting Zig is not that easy. Um, I guess I should say it's not that hard either, but um, it's undeniable that it's that. Well, I can talk for myself. I didn't fully understand how everything worked. And I mean, one could say that I still don't really understand everything, but I got to a point where I think I'm comfortable reasoning about most async await applications, and I can reason about simple event loop implementations. I'm no proti, but um, I like as a topic, async await doesn't worry me in Zig. Now, the problem is uh, there are recurring discussions about async await, and you find them in Discord. You find them probably on IRC. I don't check that as often as I should, but you see recurring discussions about async await. So while it's not that hard, it's not easy either. Like, we should acknowledge that there is something interesting happening. So with this talk, what I'm trying to answer is the question of why is it hard? Why is it that even if some people have no trouble using async await in JavaScript, for example, they still don't find it super easy to have a full grasp of what async await does in Zig? So I'm not going to. So just so you know, the goal of this presentation is not to give you an understanding of what async await is, not yet. This is a preliminary talk that is just going to try to identify where the hard parts are according to my understanding. So again, it might be wrong, but if I am right instead, this should help you identify why things are hard, and it should help you then navigate the whole issue a bit better, and you will know what to search for, and it will be easier then to cross that chasm, like make the leap and get to a point where you feel comfortable thinking about async await. This is one of the two goals. The other goals, in a sense, it's kind of the same, but from the other perspective, from the perspective of somebody that does understand async await, this talk hopefully should help you understand what is the missing knowledge in the people that don't. And so if you are writing learning materials about this, maybe this is something that you should pay attention to so that you can address common questions about async await. So let's get started and see where we can get. So just to reiterate, to be perfectly clear with the point, you're not going to get to the other end of this talk understanding async await. But if you have no trouble learning by yourself and you just need a little boost when it comes to knowing how to navigate existing materials and knowing what's up, maybe this talk will help you push further with your own independent learning. That said, it's not always going to be the same situation. There's going to be new materials coming up. I will personally work on more learning materials when it comes to async await in the near future. So this is not the final state of things. It's just to answer a need now, today, with the resources and the materials that we have. Okay, structure of the talk, 3 points. I'll quickly mention the existing materials. I'll try to point out some of the reasons why people find it hard to understand async await, and then I'll quickly say, well, what are some things that you can try doing next after this presentation? So to start with existing materials, there are a couple of talks by Andrew about async await, but these are mostly Andrew giving status updates. So, for example, in this one that I'm showing here, he's showcasing async await at a point in time where there was no event loop, I think, still, or it was being worked on. And so in his demo, he's showing, and also he's not explaining the concept of async await. He's, I guess, kind of assuming that you know what has to happen, more or less, and he's showing how async await. He's showing the feature where you can do a async call on a non-async function, and the resulting code will still be efficient as if you did a normal call. He's showing the how should I call it? He's showing the feature in Zig where you can just use async and await every time, and if you compile in single-threaded blocking mode, then all the code will still make sense, and you will not have a big performance impact because because maybe you are calling into some async await abstraction that ends up doing nothing because all the functions end up being blocking. So everything gets he's showing that everything gets compiled away correctly by showing the assembly code, the generated assembly code. And so, for example, he's showing also a couple of examples of suspended resume working, but he's like hacking a second thread that is acting as a like makeshift event loop. So again, perfectly clear if you understand what needs to happen for a async await system, like for a evented system to work. But if you don't, this is not the talk that is going to this is not the streaming session that is going to answer your questions. There's another one after that by Andrew where he shows a bit more of the event loop. Now the event loop implementation is completed, or at least complete enough to showcase stuff. So, but again, the concept is not that different from the previous talk. There's a blog post by GWJ, Dweej, I don't know. But this is an interesting blog post, Zigtastic async. But again, this is another blog post by somebody that knows what's up and is just digging into the details. So this person is using Godbolt and like looking at the generate assembly code to see what happens behind the scene every time you use await or suspend or resume. What are these operators doing? In the detail, like he wants to know which like fields are being read and modified and used as in the computation, hidden fields in the frame data structure, fields that you cannot access explicitly when programming in Zig. So it's interesting, but it doesn't answer the question either. The most complete explanations of async await, I would say, are this one and the next one I'm going to show. And both happen to involve me, I guess. But in this one, I am not the one doing the explanation. It's Andrew. So this is a talk that Andrew prepared for RedisConf while I was still working for Redis Labs. And it's a talk divided in two parts. The first half is him explaining how async await works. And he's also here explaining how Zig allows you to express concurrency even if you can't, even if you are in a situation where you can't exploit it to obtain more parallelism, and it's still the duality, which is actually the one freaking awesome feature that Zig has when it comes to async await. The problem is, again, this doesn't answer the most basic question of, well, but how does the whole thing would work normally? This is not addressed directly too much in the talk, or I would say, well, it is, but it's not a hand-holding tutorial, let's say. The second half of the talk, it's just me demoing a library that I wrote in Zig that uses async await, but we're going to talk about that later in the talk, so I'm not going to focus much on it. But I mean, it's Redis Labs, RedisConf, it's a Redis client, spoilers. The next resource is my blog post on Zig's colorblind async await, and here I am guilty of the same crime. In which I'm not explaining how async await works, how it's implemented. What I'm explaining is just the syntactic trick and how and I try to give a feeling for how the syntax still is consistent both in blocking mode and in non-blocking mode. I, for example, made a point in this talk to talk about async await without even mentioning suspend and resume. It's been a while since I wrote this post, so I hope I'm not wrong, but I'm pretty confident that, well, even if I mention the suspend and resume, they're not being explained. They're not prominent in this explanation. And I would bet that I didn't even mention them because my point was, again, just to explain the new feature, the new stuff that Zig brings to the table. But again, this is not enough if you need a full introduction. Now, this is not a lot of material. I asked in Discord if people knew other blog posts on the subject, and we got basically no answer when it comes to this material. There are a few projects that do stuff with async await, but I'll briefly mention what the problem is. Like, the long story short is that there aren't really many examples that really show you what you need to know there, unfortunately. I should have made more slides about those. I didn't. Now I regret it. But these can help, but are not the point either. So yeah, and so there's not a lot of material, and what is there doesn't go from A to Z. It just covers a limited range of what you would need to know. So why is it hard? What are we missing? And I think the answer is complicated. So I'll introduce, I think there are two main branches to why this is hard to understand. And the first one, which is the minor one in my opinion, I'll introduce it by just mentioning a couple of common doubts that people have. And so again, these are not full answers, but if you happen to have, if you had this question in your brain, maybe it can nudge you in the right direction. So again, not complete yet. So common doubts that people have, like one is like, what is the relationship between suspend and resume and async await? There seems to be asymmetry there, and you can say that suspend is the inverse operation to resume, and async is the inverse operation to await, and vice versa. But people tend to think that there is also a parallel between async and suspend and await and resume, and that's not really true. Like, you're trying to find a symmetry there that is not there. Mechanically, these things are all pretty different, and like await, like, and there is also some partial overlap between some of what of these things do. So unfortunately, you can't build an understanding based on capturing a abstract symmetry and parallelism between these four operators. Well, these two groups of operators, these two couples of operators. So you need to dig deeper. Another question that people ask is, well, what exactly is responsible for zooming suspended frames normally? Like, I know that I've been programming in Python, JavaScript, or similar languages, and I know, like, I'll use JavaScript as the example. I know that in JavaScript there is one single thread that is running my code, or like Node is not single threaded completely, but the main control loop is single threaded. You program it. You don't have to worry about concurrent access to like a global variable, because it's only one thread running your main code. So I know that when I'm writing async await stuff, there is a event loop that is juggling multiple threads of execution. And I know that it only does one thing at a time, but it keeps jumping back and forth from one task to the other. Now, how does it know how to jump? How does it know which is the next thing that it should jump to? Because, like, if I'm waiting to read from a socket, how does it know when it's time to read the socket? Does it, like, try periodically to read? Does it have a notification system? How do timeouts work? So these are reasonable questions. And the starting point to understand this, as I said, this is one half of the problem, although it's not really half. I think it's like, it's very minor compared to the second problem, which I'm going to introduce later. And I think that the starting point is to learn about kernel APIs. And by that, I mean, you should take a look at K-Event for macOS. Linux has epoll. Windows has, I don't know. Sorry, Windows is always I don't mean to say that Windows is necessarily bad in that regard. I haven't programmed Windows APIs on Windows. I think people that use Windows sometimes say they're nice. Sometimes they seem like a nightmare because things seem confused and undocumented. At least that's my impression from reading like people chat about this stuff in the Showtime Discord server. There's a channel dedicated to Windows Evented.io where you can find Leithdew and King and a bunch of other people discuss this stuff. So I don't know. My impression varies. Oh, and also Andrew in chat mentioning IO-ring. Yes, IO-ring is another one. So learning about these APIs tells you how the OS is notifying your application about the events. Now, the problem is, once you know about this, and again, in isolation, this concept is not really complicated. Problem is, once you learn about this, you are still missing how your application is orchestrating the other half of the problem. Because if you think about these APIs as them invoking a callback in your application, which is, again, I would say, might be not precise enough, might be a model not detailed enough, but it's a starting point. Well, I guess this is how I would think about it if I knew nothing and somebody told me, well, the kernel API calls into your application to tell you a socket is ready to read. Then the next question is, okay, then how am I going to structure everything around a callback? It's hard. How do I keep stuff locked until a callback is ready? Is this a promise system or what? I mean, and this is what you might think if you're coming from a higher level language, because you know that whenever you are orchestrating manually, resuming stuff, you tend to have promises, but that's not really it. That's not really it. So start by taking a look at how these kernel APIs work and what they provide. And this is the building block outside of the application that powers that brings, I would say, efficiency to the event loop, because this way the event loop doesn't have to constantly check that the socket is readable, for example, or try to resume tasks that are waiting on resources that aren't available yet. And also, I would final point on this, I would say that don't be surprised that there is a gigantic amount of variability in how these things work and how the application is structured on the other end. Like the way Python implements async await, the way JavaScript implements async await, like they are, and I say JavaScript, but I should probably say even Node versus other JavaScript engines, probably, because they don't have to implement the stuff the same way. They just need to provide you with the same semantics from the side of the user of these APIs. The variability is astounding. I was surprised and kind of disappointed to learn how variability is there and how some things are bonkers. Anyway, so be prepared also for that. That said, as I said, this is not the full story. Like learning about kernel APIs, I think, gives you 25% of the understanding maybe that's required. I think the biggest problem is the second half, which I'm going to try to express through a parallel. And I think that we, as the average software engineer that has lived their own life programming in higher programming languages, we are missing a mental model. And actually, I would say, I'm saying we as higher level programming language programmers, because, well, that's who I am. But I would venture to say that this same missing mental model is also missing from people that have experience with low-level programs, because async await is a pretty high-level construct. And so if you look at the assembly code, it's not immediately clear how everything actually, how the whole machine, how the whole dance ends up, like everything ends up fitting together and the whole machinery works. There's a few, how can I say? I don't know, maybe if you are super comfortable with assembly code, you can deconstruct everything and it fits in your brain and everything is fine. But if you don't be surprised, because it's a pretty high level feature. That's, I guess, what I want to say about people that have experience, that can read assembly code and feel comfortable understanding it. Now, I said that I wanted to explain this missing mental model through a parallelism. So let me tell you about when a few years ago, I was trying to help a friend do his computer science homework. He was a freshman, like a first year in university, started computer science. He didn't know, he knew how to use computers. He's one of those people that know how to, he knows the hardware market better than I do. And he knows how to build a computer, but he has no programming experience. He had no programming experience. So he wasn't somebody completely, tech illiterate, but he wasn't somebody that had like previous experience with programming gained, I don't know, by doing it as a hobby before joining university. So when you approach programming for the first time, and maybe the question is, think about when this was you, if you can. Because probably for the people here, this was a long time ago, but that's when you have to try to visualize. So let's say you have this simple program, right? We start with main, so we assume that the entry point is main, but then there is also another function foo defined in here, and we do these simple 4 lines inside main. So if you're new to programming, one way of visualizing this is to say that, well, we have an arrow that says which line we are executing, and we start from here. Well, we start from the beginning of main, and then we go down line by line, one at a time. So, well, the first line just declares the existence of x. Well, it also sets to 0, but maybe that's a detail that you don't care about much when you're learning. And then you notice that x is being modified. So you can even think of saying, well, x lives in that line, and I'm gonna change what the value stored in that line is. Then we move to the next line, and my 3 disappeared because I did mess up my animations. Apologies. So there should still be a 3 there. So we move to the next line, and you've been, so function calls, maybe you don't know about them in the beginning, but they are not that hard of a concept, right? It's a procedure that gets bundled under a name, and it's reusable. So you know that we are calling into foo, and we are passing x. And then, again, this is another non-trivial thing that you learn after. This is not like a mathematics, this is not an equation where both sides have to be true. Like this is not like x and x here. They need to be like, you'd have to find a stable point or whatever. No, you pass the current value of x downstream. Once you're done evaluating foo, then you set the resulting value into x. So this is not a gigantic. Some people have questions about this too, right? Maybe you did when you were learning, but you get through that. It's not that hard. So then you know that if you're calling into a function, there is like a subtask, a sub pointer that executes what's inside that function, and you pass in the argument, which is going to be 3. You substitute every instance of that argument here. Then you know, oh, it's 3 times 2, so the result is going to be 6. And then you know that the new value for x is going to be 6. And this should have been a 3 that changed into a 6, but it is what it is. Then, next line is print foo. Print foo x. Now, you're calling into the function again, and what you learn after a while is that you need to reset the state of the function that you're calling it, because if you call a function a second time, everything starts from scratch again. So n is not 3 anymore. N is going to be the new value of x when we call foo. So this is not hard to imagine, because you can still use the same trick where you say, well, I'm going to use where the number is written in the actual listing of the code to make space for my new value. I substitute the name with the current value, and I compute the new value, which is 12, and you print 12. Nice. This works, and you can understand programs this way when you're getting started. But at one point, you encounter something that kind of breaks this mental model, or rather, it forces you to think about something that you could ignore before. More precisely, if now main is still the same, but now foo is doing something different. Foo is a recursive function. It's computing something different, And the problem is that it's computing something different using itself. And that's a nightmare, because previously you could think of the lexical, where the, where the name is defined, where a symbol is used, you can substitute it with a new value. But when foo, and when using a function 2 times, to separate times, you just have to think about resetting foo with your to a empty state. But when you have foo call into itself, you cannot use this spot anymore to put a value in, because you have to think about and actually I think this should be sorry, there's another error. I think this should be n plus switch this. So yeah, this should be n plus, sorry. So you have to think about the fact that foo survives, well, a particular call to foo survives before while the other call is existing. So you can't use this mental model anymore. It's not detailed enough. Previously, you could get away with it because the stack was still there, and yeah, that's the point. So the thing that you're forced to think about now and to understand and model the existence of is the stack. And it doesn't have to be the stack like in the practical terms of how it's implemented in our architectures, but you have to understand that there is some other space, a table somewhere else, where you need to keep track of n for multiple nested calls. And before it was the same too, but you were never forced to think about it because your simplified mental model was detailed enough to get you away with that understanding. Now, can you still remember when you used to be confused by recursion? For me, it's been a long time, but it's not a secret that recursion can be confusing. And I think that my hunch is that with async await, we are in a similar situation. Even though we are experienced programmers by most definitions, I think we still have a blind spot that probably our education nor our professional life has covered. Some people actually do. So, by the way, the point is, this is not for everybody, right? If you're somebody that had previous experience implementing event loops, yeah, I'm sure this is not going to apply to you. But if you've, I don't know, I'm a bioinformatician, so I've done bioinformatics and web stuff and enterprise development after that. And then I started using PowerPoint as my main IDE when I became a developer advocate. So, I never, this corner of knowledge of how a specific system works was never stressed. This was just a muscle, a weak muscle in a sense. So recursion forces you to acknowledge that there is a stack. And async await forces you to acknowledge the existence of non-sequential multi-threaded control flow models. When you use async await is like a go-to on super steroids. So you now, before, you were used to a control flow that it was fairly sequential, you know what's going on, but now the control flow is jumping around in weird ways and different threads are executing this stuff, not just one. So this is your new reality, and async await forces you, or more, I would say maybe more precisely, it's continuations. Continuations have been confusing, I think, since forever, and I think they have confused everybody in all of history. So it's non-trivial stuff, and it's non-trivial because it's forcing you to face something that you could easily factor out from your mental model earlier. Now you're forced to gain this new extra level of detail in your model to be able to understand what's happening. So let's mention a couple more common doubts. So I heard also questions like, well, what does suspending a frame mean in practice? And how can a suspended frame be running code? If you ask this question yourself, the answer, again, not an answer that is going to explicitly satisfy your understanding. It's just to nudge you in the right direction. The answer is that you're thinking of a frame as an active piece, but frames are actually just a bunch of data structures. It's a bunch of code plus some state. The active agents doing stuff are threads. So this question should be probably reframed in what is happening with threads and the suspended state of a frame. And the answer is not simple. Or say, well, the answer is not immediately trivial. So you need to get there. But you should not be thinking of frames as active things. They are passive things, at least in Zig. Another question that I heard is, well, if async functions don't have a stack, how do nested async calls interoperate correctly? And that's another interesting question, because like if you know that you have a bunch of async functions that call into each other and they suspend at different points, and then you know that a frame can be executed, that can be resumed by another thread. Are threads swapping stacks around or what? And I think some other languages do this stuff, but in Zig it doesn't happen. So how can that happen? And the answer is based on understanding the async calling convention and how some things become frames themselves, while some other things can get away without having to do that. And once you understand this particular sub-dance, like this particular set of dance moves, then you understand the bigger dance routine. Again, I'll repeat this every single point. It's fine if the answer that I gave right now doesn't really satisfy you. It's not meant to satisfy you. It's meant to push in the right direction people that are asking these questions that are on the verge of understanding. So these are another couple of questions that I heard somewhere else. So and the problem is then, so why does it hurt so much thinking about this stuff? What's up? And the answer is it's because you've been an async await user all your life. You never stress this muscle. And now with Zig, you are being forced to look at the metrics. Or actually, what I should say is probably not that you are being forced precisely, but now looking at the metrics is an option. In other languages earlier, like in JavaScript, I think it was never an option to some degree, like you cannot inspect too much, or I don't know, maybe there is some metaprogramming stuff that allows you to peek into what's going on in the event loop. But the point is, it's not something that you would normally do, or that you would have to do to understand what's going on, because your level of understanding at that level of abstraction can still use the same simplified model. That said, it's not like Zig is forcing you to really... Well, I would say that if you're programming in Zig, you kind of want to understand a little bit more because you want to be more precise with how your program is structured than you would normally be with your average JavaScript application. But Zig is not really forcing you to understand everything. And as a practical, like case in point demonstration of that, I did this with OK-Redis. I wrote OK-Redis before getting to where I am now. When I started writing OK-Redis, it was way before I would say I knew anything about epoll or k-event or IO ring. Not that now I know that much actually, but now I know a little bit more. At the time, I didn't know anything. Like if you ask me what is the kernel API on macOS that gives you notifications for events, I would say I have no idea. But I was still able to write this library, which is a working Redis client that works both in blocking mode and it works also in async mode, in non-blocking mode, in evented IO mode. So how is this possible? The answer is that, going back to what I was trying to say before, while Zig is giving you more control, and you want a bit more control than JavaScript because ideally you should be writing more precise, more optimal software in Zig, you don't have to buy into the entire complexity if you constrain yourself to certain use cases today. OK-Redis, as I said, it's a client library. It just uses this stuff that the standard library network, the networking part of the standard library offers. I don't use suspend nor resume anywhere in this code base. It's just normal async await. it's not that different from what you would write in Python. Not exactly the same, maybe. As I said, maybe a little bit more understanding, but not the complete understanding of how everything works. My argument is that if you want to start getting into async await, writing client libraries for stuff, it's a great starting point, because with client libraries, you can still be a async await user. You don't necessarily have to understand all the implications into how the event loop works and how the finer details of async await and frames are. So client applications are perfectly doable, maybe with a star, because you might find the occasional bug, I don't know, or because, for example, not all operators, not all the async operators are there yet. I think there is an accepted proposal for another operator called select that allows you to kind of wait multiple frames at the same time and react whenever one is ready. Today, this is not really possible the same way. And so I wouldn't say that all client applications are perfectly doable, but especially when it comes to libraries I would say are nicely doable. I would say maybe you can consider, okay, Red is an example of that. I think one of the downsides is that I'm going a bit heavy with metaprogramming in it, so you might not find everything as straightforward as it should be if you were looking for something that shows you a usage example of async await. But that said, there is no weird async await stuff in there, and at the same time, it's something that actually works. So yeah, consider taking a look at client libraries. Also, another reason why client libraries are your best bet, in my opinion, today to get started is because applications, and more importantly, servers, tend to require resource management. Like resources tend to have life cycles, and that makes it harder. It forces you to think more about what the event loop is doing precisely, and you have a more active role. So server applications, server libraries, since they have to manage resources more explicitly, and complex client applications also have to manage resources, they might be a bit hard to get started. But client libraries are not, because they tend to, in the client library, you don't have to do much resource management most of the time. Or at least this wasn't the case for me with the Redis client. And I would bet that if you write a client for another database, as an example, you would probably find it that it's not that different, and that you also don't have to do much resource management, so you don't have to reason about the complex stuff. You can just use async await to make sure the stuff, ends up being easy to juggle in the whole overarching architecture of the final application. That said, you can still write simple applications that try your code. So you can write a simple, I have a bunch of example applications, test code, I guess. I think of it as test code that tries the client library and tries to do simple stuff. So it's not like you have to write a library, you can't use it. You can use it. The problem is when it comes to complex client applications that do a lot of stuff, because then you fall into this resource management conundrum that might be hard if you're just getting started. I have also a life hack. Do you really want to get to the other hand knowing a lot about how async await works in Zig? In my opinion, a great life hack is to implement an event loop. What I did was take the standard, the event loop implementation in the standard library, and in a fork of Zig, I removed every function in there. I wrote a simple script, like a simple script that just contains like open a socket, write to it, read, close. And if you know, in Zig, if you're not using a function, then that doesn't even get analyzed. So by having a super simple test application, you don't have to re-implement the entire API of the event loop. You can get away with implementing just what's actually needed for that use case. So that's beautiful, because then you know precisely which are the functions that interact in that specific subcase. You can take a peek at how everything is orchestrated into std.net and the upper level FS and FS and net and the lower level of OS. And you can see how control passes from one part to another. And then when I say re-implement what the event loop does, it could be even as simple as copy paste back the actual lines of code that are needed to implement that. Maybe trying to read them. So you need to find like a balance between, you need to do some work, right? But it's not prohibitively hard. I went from knowing nothing to understanding this, and I think you can do that too if you are just willing to put in a little bit of effort. So this is actually the conclusion of my talk. It's not more complex than this, and but there are a couple of takeaways that I think are important. So to really recap the points that I wanted to make. If you're interested in async await, consider writing a client library, and you can test it writing a small application for it. That will show you that you can be as productive in Zig as you are in your higher level languages when it comes to just being a sync await user. So you will see that since there is not a gigantic ecosystem of ready applications, you can't do everything with the same ease that you are able to in JavaScript. Like if you want a HTTP server, there aren't 10,000 HTTP servers ready for you. There's Apple Pie that is being worked on now by, I think it's Firefox. Am I misremembering? Yes, no, it's Nipsey. Nipsey is working on Apple Pie, and I think there might be a couple more implementations. But again, maybe you try the application and it's buggy and there's something that doesn't work as it should. So, yes, today there are a couple of things that you cannot really do in Zig unless you implement them yourself. And implementing them yourself requires you to know more. But when it comes to standard client libraries, you can be really as productive as you are in other languages. And you can enjoy really how things are so much nicer in Zig. Like I loved that my Redis client has one code base for blocking mode and async mode. This is something that you can forget when it comes to Python or other languages. So it's not just doable, it's doable and nice. But if you adventure yourself into unexplored territory, yet when it comes to server applications, unfortunately, yes, it's still you have to learn more once you start factoring in resource management. Another thing is, learn about key event, epoll, etc. But know that that's not the full story. And if you go that route, you might want to really take a peek at the event loop in the standard library and use that as a guide to really understand from start to finish how your simple open socket, write hello, read a line, close application works. Because you can do that by shrinking the scope of the main final application. You can shrink the scope of everything else that you have to look at in the code. And once everything fits into your mental model, then you start understanding more how everything works. That's still not gonna give you the full understanding when you start having multiple threads jumping left and right and moving control flow, but that's something that we can tackle in a different way. And and that's the final point. So my final point is understand that you might need a more detailed mental model for multi-threaded continuations. Like when you need to fully understand async await, you need to appreciate how it's possible for chunks of execution to move around without messing around with the actual stacks of each, interoperating correctly with the stack of each thread and how everything works. It's not crazy. Again, I'm not attempting to give a half-baked explanation of this because I would like to give a proper one in a dedicated talk. But you need to get there to really understand everything, in my opinion. And finally, I promise to work on some more learning materials soon. Just give me time. I'm working on the website, and maybe there will be other priority. But to me, writing stuff that help people understand async await, it's fairly up there as a priority because I think it's a very exciting feature of Zig. So right now, I'm mostly, for example, waiting for select to happen so that I don't end up, preparing a talk on async await that doesn't mention select, which ends up being something very important, and then the talk becomes obsolete, like at the speed of light. So I'm trying to be, how can I say, efficient also with my effort, and there has to be a balance there. And that's pretty much it. So that's the end of my talk. Thank you for listening. I hope somebody here now feels a little less confused about this stuff. I know I didn't answer anything completely. I just gave hints and stuff, but at the very least, know that if you have trouble with some things, you're not the only one. It's not you having issues. We can get there. We just need enough learning materials and the ecosystem to stabilize a little bit so that the learning material doesn't become obsolete at the speed of light. So Andrew says, one note, applications can choose a single-threaded event loop and get a programming paradigm equivalent to Node.js. Yeah, but library should handle the possibility of multi-threaded event loop and to make a compile error, or to make a compile error if built-in single-threaded is, well, I would say it's different than true. Have actor models been explored in Zig? Oh yeah, Andrew answered. Oh no, Andrew did not answer. Let's see. Nectar says, I've seen some whispers, but I'm not exactly sure what the status of the conversation currently is. I think there are some... there is some code maybe in the standard library. I'm actually not even sure, but I think I wouldn't worry about this because all this stuff is perfectly implementable. Maybe the only issue that I would see there is... I think there are two issues. One is a practical one where maybe in other languages, if actor models are like hard-coded into the language, you can enforce people, like you can force people to use them in a certain way, while maybe in Zig you would leave it to the user to make proper use of the API and they could accidentally break away from it. This is a super general statement. I'm not even sure that's true, but that's one thing that might happen. And the second point I think is that actor models, I guess, are nice for correctness and ease of use sometimes. Kind of like Go with coroutines and channels are basically a poor man's actor model. I don't know. I think of it. I think what Go provides you as a poor man's actor model because I'm comparing it to what like Erlang offers. So it's what Go gives you is much less fancy. Even though I honestly like it, so no complaints there. So something like this is certainly doable. I would say that the philosophical problem there is that, well, if you want to make things efficient, you probably should not constrain yourself to a model like that. You probably want to try and squeeze in weird control flow, weird, quote unquote, weird control flow things, at least weird compared to what the actor model offers you. So I think it would make total sense for that to be a library somewhere. It would totally be implementable. Oh, there is a library, Drone Wings Saville. Okay, interesting. So I haven't really found. So Komari says I haven't really found something I want to implement that would need async await yet. So I haven't really played with it. Yeah, I think that really the entry point for this stuff, no joke, is client libraries. Client libraries are, I think, like the perfect scope for getting started because it keeps you on the async await API level. It doesn't force you to get into suspend resume. Or I should like the asterisk there is that like the small lie in what I'm saying is that it doesn't force you to go into the suspend resume layer as long as you're using the APIs in the standard library. More specifically, well, you clearly would use the APIs in the standard library. Well, I don't know, not clear, but you would normally use the APIs in the standard library when it comes to networking, for example. That makes sense. But for example, for my Redis client, at one point I needed a locking mechanism that would work well with the async await, and that would also maintain ordering between different threads asking and queuing themselves to get access to a lock. I needed that ordering to exist because unordered access to the lock would cause all kinds of trouble with the architecture that I went with the client. So If that library wasn't available, then somebody would have needed to, I would have needed to write it, and that kind of requires to use suspend and resume. But the library is there, so to my understanding, you can write a reasonably functional, full-fledged kind of application, kind of like I did for Redis. Pick your poison, find a database that you like, and start looking at how you can make it both work both in blocking mode and in a sync await mode. And again, I assure you, you will find it's surprisingly easy. I should probably do a talk dedicated on that. I should probably explain how okay Redis is structured. It should probably be an interesting talk on two fronts. One on the front of, well, how async await is integrated in it, and really the integration surface is so small because everywhere there's this automatic translation between normal calling convention and async calling convention, and the other half is I guess would be metaprogramming. So yeah, think about it. Like maybe you can write a MongoDB client for Zig. I'm not gonna do that. So somebody should. And please, for the love of God, don't let Mongo, what's the name of the company? Whatever. Don't let Mongo itself write the client, because they are so bad at it. I don't even know where to begin. Anyway. So I don't know. Redis, I think if you want to, I'm biased. I like Redis, but if you want to try your hand at something that is simple to implement, not too like the query, the communication protocol is not too obtuse. It's nice to debug and everything else. Take your step at Redis. Maybe you can write your own client, and it's they're bad at writing servers too. Yeah, they are. Oh god. Oh my god. Don't get me started, man. The hardest part of working for Redis Labs was that I could not talk as much shit as I wanted about MongoDB. That was genuinely the hardest part. Anyway, a Sqlite client. Oh, that's interesting. A Sqlite client. The problem though is that Sqlite it's not worked. So I have a use case for a LevelDB equivalent API. Necro also said, did you go over the relationship between async await and suspend resume, and why there's both? I didn't go precisely over the reason why, but I mentioned that these two groups of keywords are very, very different. If you are expecting asymmetry, so that somehow async relates to suspend and await relates to resume in a somewhat clean, abstract way, they don't. They do very different things, all of them. And as I said, also there is a bit of overlap. Like await kinda does some of the things that suspend resume await uses, in a sense, resume. So no, that's not even right to say. So in any way, what they do is a bit overlapped, and you need precise knowledge of what they actually do. You cannot reason about them in an abstract way. And what they do ties precisely into how continuations make the control flow in each thread jump in different points of the code. And here's the thing: you can see that already. Like I think Andrew gave plenty of examples of how this control flow manipulation works in videos, and also in the documentation, the standard library documentation, which, goddammit, it's another thing that I forgot to mention in the list. Like in the docs, there's also some examples for these. The problem is, while they are perfectly clear, when I personally saw them, is you understand the example in isolation, but you still have trouble seeing the full dance, or at least that was for me. So my actual, the question that I'll try to answer, that I need an answer to before preparing a talk on async await, is how to fill the gap. How can I bring people from understanding a example in isolation to understanding how this scales up to a full-fledged application? And as I said, the entire juggling, the entire dance keeps making sense. I'll get there. I suspect it's probably not too complicated. It's just a matter of properly identifying what the key parts of understanding are. And as I said, this is really, I think, tied to our like the zeitgeist of software engineering. Today, I think these things are not really stressed much in our education and in our professional life. And if they were stressed more, we would probably have less problems, or I guess different types of problems. But yeah, I'm thinking about this stuff constantly. So I'm sure I'll get to a maybe not the perfect solution, but something that can help a few people at the very least. Suspend resume is for bad boys. Yeah. Mm. Oh, another thing about a little Postgres client. Nice. Is it a gap that needs to be filled? Well, I think we would want people to. So I think there are two answers. I would say yes, and I think there are even two separate yes to that question, at least from my point of view. One is, well, as part of my role, I think having more people be able to do more stuff with Zig is important for what I'm being paid for, and I guess in more general sense, I want personally people to write a good async stuff for me, so that I don't have to. But on the other hand, I would say if we don't do that, the result is the madness that you find in Python, for example. Like the way people implement a nice looking layer of async APIs for you in those ecosystems is crazy. The things that Python and JavaScript do behind the scenes is crazy. I know I'm being imprecise and hyperbolic, so it doesn't sound particularly well, but there are so many weird things that these languages do to hide the complexity from you. Like in JavaScript, I don't know why, but if you have a promise that results in another promise, await will unwrap all the promises. So if the return type of a promise ends up being another promise, await will unpack both. While for example, I was writing an API where there would be two precise moments. One where you want to await the code that produces the resulting promise, await that, obtain the promise, do some stuff, and then await the promise that you were given. But it couldn't work with JavaScript because await will unravel, like unpack, unfold. I don't know how you want to say it. Would flatten the entire promise functor structure. I don't know. And why is it doing that? I have no idea. It's janky. Everything is janky as fuck. So in Python, if you instantiate in Zig, if you do async function, the function runs immediately until it encounters a suspend point, which makes perfect sense. In Python, if you launch a coroutine without awaiting it, which is the equivalent of using the async keyword in Zig, in Python, the coroutine gets just instantiated as an object and it doesn't run. It doesn't do anything until you schedule it through await or a similar operator. And there are so many of these weird inconsistencies that then if you go and look into the implementation, you see that everything is glued together with like gum and a couple of nails and a bit of wood, and everything tries to kind of stays together as long as you don't stress it too hard. So I think there are a lot of downsides to having people like that status quo is what you get when people can't make the jump from understanding async await to understanding continuations. So I think if we want to make things better, we should try to aim for people to get there. Again, I'm saying this at the end of the day for completely selfish reasons. I don't want to deal with crappy stuff like that anymore. I would like for everything to be maybe not at the maximum efficiency like Proti likes, but I would like stuff not to be janky at the very least. So yeah. I can tell you that when I started implementing slightly serious async stuff in Python and JavaScript, and I mentioned JavaScript earlier, but like Python is so much worse at this than JavaScript. Like the APIs are all over the place. So Nectar says Go is a better model there, right? One of its main things is people complimented on its async model. I would say that Go is better in the sense that it's more it forces you to do fewer things, and so people don't do weird things. But Go is not. But Go is strictly. I would say the Go is strictly less efficient. Like using channels and Go and Go routines is strictly less efficient than what you can do with async await, because async await is a superset of what Go does. So I would say that in the best choice, like the best world, would be to have people make proper use of async await, and occasionally when you're writing software as a user, you might want to opt into a simplified API that maybe you are more familiar with to make your application work and not worry about weird bugs. But that said, Go is inherently Go is not the optimal choice. Go is a good choice if you want to make sure that you don't if you want to, I guess, prototype your application. If you are familiar with that API and you're comfortable with it, you can use it. That's my point. But it's not something that we should, I think, aim for when it comes to writing like actual libraries. Actual libraries should use async await and make full use of the proper async APIs, using suspend, resume, and smart ways of locking and not locking stuff. And Proti has a lot to say in that regard, so I'm looking forward to his talk. We should be next showtime, but we haven't finalized it yet. So let me read a couple of comments. Oh yeah, I was only referring in comparison to your JS Python example. Yeah, no, I agree. Compared to I don't know, honestly. So I would agree 100% with Python. Python is a mess. There is a library called Trio, which I think brings some sanity there, but it brings some sanity from a API perspective. I haven't inspected the implementation, so I cannot comment on that. But let me rephrase this. Let me put it this way: from a productivity point of view, and as the end user that ends up having to deal with the resulting software that the world produces, in my opinion, Go is vastly better than Python when it comes to async await. Compared to JavaScript, I'm not sure, because JavaScript, I think, while it's not perfect, has a much saner ecosystem culture around async stuff, and while, for example, I found annoying the thing that await unwraps everything. I think you like every time I had to write something that had to do async stuff in JavaScript, it tended to be much more straightforward than Python, because JavaScript has pipes, everything tends at worst to accept a callback. So yeah, that said, I don't know. I personally like Go, so I tend to be very positive of Go. But I have to admit that I think JavaScript is probably not that bad, at least in my experience. So let me read a few other comments. Zig's Sun Library async event is equivalent to a concurrency async await, I guess, is equivalent in a concurrency sense to how Go runtime works. The differences are only in memory management, the ability for async functions to return values. For example, we can implement Go channels in userland in Zig. Oh yeah. I would love to see Go's async style done in Zig, mostly because I don't know much about the underlying implementation for Go. We don't have Select implemented yet though. It's an accepted proposal, yeah. So yeah, we need Select. And since Matt says also, and since I work with Go devs, that would help talk Zig async versus Go async. Oh Oh yeah, yeah. Proti points also out that there's some examples of Zig in the Zap repo. It already has channels where groups go, and recently with Lithium's help, IO. Oh, yeah, nice. Oh yeah, that's. I don't know, King. Are you going to present about Zigo in your next talk? Go rid of color. Got rid of color entirely. Um, I think Nectar, if you haven't watched the Redis Conf talk, I think you can give it a look. I think Andrew answers answers some of that. Yeah, you can always go something, and that's it. The problem is that if something was supposed to return a value, now you have to synchronize with the channel, and that kind of ties you into a model where you don't always like you don't always not always everything looks as good as it should, and I guess works as efficiently as it should when you have to chuck a channel in the middle every single time. And I think you can do better with async await when it's used the right way. Okay, Proti wants to do the talk about schedules in general. Okay. 190 YouTube subs to partnership. Yes. Thank you also. Me and my other accounts. Yeah. I'm so close. I really want to get this freaking partnership because Google, I mean, I don't know what's up with the world right now. 2020 is, and it's not gonna be over after 2020, but I don't know. Google now wants to add ads to everything. At least they could do the decency of paying for some of the t-shirts that I have to send to speakers, for example. I think we can do exclamation point YouTube. They do a good job with the bot. Yes. So yeah, there's also that. Well, in any case, I think that async await is a very, very interesting topic, and we should talk about it more in the future and from different angles. And we need more applications to use that. And I think that once we start showing how we can be faster and more efficient than quote unquote the competition, people will be more interested in doing the stuff in Zig. We get more libraries with more stuff, and everybody is happier. I mean, if you are here for the 0.70 release party, I don't know why I said 0.70. That shows you that when non-native speakers learn English, they learn a mix of everything, and anyway. But in that Showtime episode, King Proti from the chat demoed his own scheduler and compared it with an equivalent implementation in Go and Rust, and the Zig implementation was pretty damn fast compared to the other two. So there's space for a lot of interesting things to happen there. So I'm also looking forward to writing spicy blog posts in that regard.